So I'm really excited about the panelists we have. Once again, it's a diverse group of people from different perspectives that have different perspectives on the industry. So let's start similarly to last time. And we'll start with John Schroeder, who's the Senior Vice President of Engineering for E3 International. And I think E3 is a more newly established company, so maybe you can introduce what you do as E3, and then in terms of what's your biggest target for cost reductions in terms of components or pieces of the value chain
Sure.
you're looking
Thank
at.
you, MJ. So yeah, E3 is a very new company. We formed in earnest about 6 months ago with the business that we think that development support, EPC, O&M can be a competitive business in its own right, and that there's a whole lot of value there to be picked up. The question was, where do we see the biggest opportunity for BOS cost reduction? And I would answer that there's 2 locations. One is there's still a whole lot of, well, let me back up a second. The one place where you cannot screw up is increasing risk, because in today's market, the cost of capital greatly trumps the cost of BOS in terms of the cost of energy. So get that out of the way. But I think there's 2 places. The inverter still has a lot of ways to go, especially as the DC voltage system increases, and the tracker. The tracker, I think in 10 years we'll see tracker as same price as fixed, mostly because a tracker is smart enough to get out of the wind. So a tracker should have less steel than a fixed tilt in theory over time.
So you're saying the savings in terms of the steel should pay for the motors and the
Yeah, and on an
parts.
energy basis, a tracker should blow a fixed away, because you'll get 15 to 25% more energy out of a tracker, and you should have the same material cost. Again, I think we'll see that in the next 10 years.
And I just want to point out that with John, it's not like you guys are new to the business either. You're a bunch of veterans from First Solar.
Yeah, we're kind of full of ourselves. We have some pretty good resumes, but we don't want to rest on that. So.
Sure. Okay, well, Larry, let's move to you. Larry Truong is the Director of Business Development for Power One Renewable Energy, soon to be ABB officially. So John thinks that you guys are charging too much for the inverter. So in terms of cost reduction on the inverter side, is that the biggest opportunity there, or do you see others?
It is kind of tough sitting next to John and talk about this. I think I have scars on my back to actually prove the points. But thank you, John, for bringing it up. Yes, inverters, we believe that there are different types of cost reduction opportunities. I think with the nearest term we can look at is optimize the design of what we call the smart station. Currently, a lot of inverters have been deployed in the utility scale, come out on the skid. And the skid here, you will have the cost of the materials, the metal, the concrete, the cost of cabling that goes underneath it, the engineering and design of the skids. And those actually add probably about 3 to 5 cents per watt into the inverters. And I think that the shortest path today is to, how to eliminate that cost and yet retain the kind of benefit that the skid design will bring to the market. For example, the skid design will actually minimize the type of labor out in the field, especially when you're dealing with union labor. And also it improves the quality of the system, because the system being built in a controlled environment. So we're looking forward, and if we want to take out the skid, there are ways to do it to maintain those 2 benefits, and yet take about 3 to 5 cents out of per watt out of the inverter cost.
So when you say the 2 to 5 cents a watt savings, that's coming from just the labor, or what does that all include?
It is actually, you look at the whole skid, basically, the material, the engineering and design, the cabling cost, and especially shipping costs. You want to ship the whole, big thing down, to the long distance. So.
Okay, well, I want to, with that in mind, I want to move to Dean Solon, who is the CEO and founder of Shoals Technologies Group. And you forced me to to not beat you up too much, or I wouldn't have access to the reception tonight. But I know that you know a little thing or two about skids, right?
Yeah.
And maybe you can respond to what Larry's saying, and then also with your involvement on the BOS side of the industry, where else do you think you can drive out costs?
Well, one of the things it's kind of interesting because we've been focusing on power skids for about the last year, and we're playing with Lectris. So Shoals and Lectris kind of have a JV on power skids. And what we've done is we've converted the skid into a plug-and-play device. So you could actually ship 2 central skids, the transformer, all on a standard flatbed straight to the site. So it's a plug-and-play. You take anybody's inverter, we put electrical connections inside the inverter, and it could either be built at Shoals Lectris, it could be built at your factory, the inverter guy, or you could build it out on the field. So we don't care where it's put together. It's basically a plug-and-play solution. If your transformer arrives late, we don't care. You could still drop the inverter stations in place. It's a plug-and-play within an hour or less. You have 2 skids and a transformer assembled on site.
So I want to ask actually a follow-up question real quick, and we'll jump into this topic a little bit later. But it seems with a plug-and-play solution, you might be, you have to accept everybody, right? And
Yes.
so you might be sacrificing some cost there versus an optimized solution. Is that true, or what is the magnitude of
No,
that?
it actually isn't, because what we've done is we've taken 6 different inverters so far and have optimized the skid to be almost the pure identical solution. So what we're doing is we're building these frames in a factory condition, basically have them waiting on a shelf to be integrated again within our factories, within the inverter guys' factories, or on the job site. So instead of every skid being custom made, custom manufactured for that person's skid, and the issues most skid guys have is all the inverter guys have had great reputations, and the skid integrators have given them all a black eye, right? It's that simple. Just from defects, people who were building a lot of one-off products that all of a sudden had to order for 1,000 devices and couldn't scale up. So all of our customers have pushed us to where this is a pure open architecture plug-and-play solution, and we're already delivering them to jobs.
So everybody loves to pass the buck on reliability, but pushing it on the skid guys is a first.
I'll take the liability all day long.
But
We're
in terms of
building it right.
But in terms of other balance of systems, where do you see the cost reduction opportunities there?
So the other thing we've done from the BOS side is we're now building our typical Shoals harnesses. Currently, they're like 10-gauge devices, 8-gauge devices. We are shipping them as 4-aught devices and 1,000 kc mil devices. So in all UL listed, we have very large aluminum cables with branches coming in 10-gauge, 8-gauge, 6-gauge, whatever gauging you need for that branch, fused, going into that big aluminum bus system straight to the inverter. So half the combiners finished, gone.
Before you even get out to the field?
Yes, they're removed. And we're into combiners, but we don't care. We're trying to get this field optimized as quick as possible. And it is our goal to have the complete system installed by general labor, not highly paid electricians out there wasting a lot of people's time and money.
We don't have any.
It's got to be done by general labor. End of story. I know I'll piss off a lot of licensed electricians, but until it's done quickly and easily and delivered to a job site as a true plug-and-play, you're basically just another Me Too guy catching up to the guy who's racing to the bottom.
Sure. If you're a licensed electrician, by the way, you can drink more tonight, and you're taking out
have an extra one on my behalf.
Dean's bank account. So I want to, and then finally, Mark Kingsley, you're the CEO of AlionEnergy, and you have a pretty interesting perspective. As I understand it, or you explained it, Alion is a DC-based service provider. So maybe you can explain what that means.
Our challenge, I think, and I'll build off some of Dean's comments, we're trying to create industry. So we can't avoid doing everything under control to take cost out. And that's what Alion was founded around, was looking at the complexity of installing utility scale doing traditional tools like design for manufacturing and assembly, looking at the labor, the logistics, the parts. And what we said is you have to use tools such as automation, changing materials, consolidating parts that you've heard here to actually design the cost out. Because if you don't design
cheap
cost
labor.
out, you're just waiting for inflation to put your costs back in.
You forgot cheap labor too.
And well, the robot does that, right? So, I mean, what we're doing is we have robots that install panels, 10 seconds for every panel. And then we also have cleaning robots, so back to earlier sessions around keeping the energy efficiency up there. You know, people will invest $60 billion to get 2 more points of efficiency in cells and then give it away with dirt. So we think if you look at the total system cost, it's now at a time where standardization and automation can really take out significant cost.
Sure. Is that, I'm curious about from an, more pure EPC perspective, John. Is automation something that you're looking at? Does it pencil out?
So, to be honest, the back of the napkin.
We're not allowed to lie to the industry. Just remember it.
So I haven't looked at it, and this is one of the reasons I was very excited to be on a panel, because before we were talking about, I'd love to see the system that would make that work, because in my experience on BOS side, I have a hard time having it pencil out with the baseline concepts in my mind. So I'd love to see it.
Sure.
Last time I saw a robot in the field, it was Applied Materials with a giant crane and things like that. And then at First Solar, we tried some things robotically, and we just never got them to pencil out. So,
Dean, you don't have to pay or feed robots. Is this the ultimate?
I like Dean. My robots like Dean, actually.
Exactly. Well, the other thing too is the only way you're really going to get disruptive technologies installing a field right now is getting labor off the field. No matter how you do it, it's got to be just plug and play. I mean, the biggest, everybody's still, module prices have come down as much as they can. You could beat up the inverter guys, but they've all been squeezed like crazy, right? The BOS solutions are squeezing down like crazy. The next big portion of that install is labor. So you got to get that labor off, and it has to be done in a factory environment where it just drops into the site, and anybody can take an hour training course and be installing a utility grade field.
Descale it.
I'm kind of over exaggerating, but that's the point where it has to be.
Sure.
Or it's just not going to grow.
So Larry, you talked a little bit about the skid solution. Is there anything else that power electronics can do to help on the labor side of the equation?
I can't, imagine that the inverter is being built or being installed out there ever bought it. So I'm not sure I have any meaningful input to this topic.
Sure, no problem. Okay, well then moving on to, let's look at some specific ways that we can drive out costs. We've talked about a few of them, but one thing that always gets passed around is higher DC voltage systems, right? Move-in utility from 1,000 volts to 1,500 volts, eventually 1,700 or 2,000 volts. So GE and First Solar made an announcement that they're doing one in the US, Electric, and I think GE in the past have done one in Europe. But where are we actually in the movement towards higher DC voltage, and when can we start to expect to see the utility systems be mostly 1,500 volts like they are 1,000 volts today? Anybody? Dean?
We're shipping harnesses already to 1,500 volts.
Yeah, I think it's quick. I mean, it's not, we've already done this transition before as we stepped up to 1,000. All the tier ones that I've been working with out of China have these programs, and people are already shipping to them.
we're on to 2,000 volts over here.
Okay.
MJ.
Well, so then 2,000 volts. No. Well, Larry, you guys have a 1,500 volt inverter that's ready to go for these guys?
Well, all I can say now is that it is some of the serious topics that we're working on. Mm-hmm. And I just want to take this opportunity to actually raise a point is that as far as inverters are concerned, typically the cost is proportional to the amount of current flowing through the inverter. So raising the voltage will naturally reduce the current and to bring the cost down. However, when you start moving to the 1,500 or 2,000 volt, we have to remember there's an ecosystem within the inverter and in the PV plant that goes along with it. And the question is, are those components, are those parts are ready and at the cost that it needs to be? So yes, we loved the idea, and we think that will be in the short term even will be some of the key drivers to lower cost. But we'd like to, to remind that, that we need to have that ecosystem to come along with the inverter, so that cost reduction in one area doesn't, necessarily go into the other side.
So what part of that ecosystem do you see as kind of the one that's lagging behind right now, the one that's making you pause about 1500 volts?
I'm not sure it is lagging behind is the right description, but I think that having the components such as, cabling, approved cablings, the protective devices, and things like that are available in quantity, in the volumes that actually, can help realize in the cost reduction.
Sure. So, Dean, basically you're charging too much for your 1500 volt harnesses.
No, actually, we're not. It's brought the price down, quite honestly. But the issue people are having with 1500 volt is, as usual, the IECs and the ULs of the world, trying to figure out what the hell to do with it. And it's one big confused mess that needs quick standardization on what the subjects will be, and that'll help clean that mess up quickly. But right now, everybody's saying they're recognized to UL, they're IEC 1500. We need that mess cleaned up, because 2000 is not that far down the road.
Right.
Yeah.
Okay.
I mean, I was going to add, the regulatory approval delays, as we know, can actually add in the additional cost to the system.
And not to pick on Larry too much, right? But
I'm used to that.
the main savings are going to be the longer strings, and then a little bit of wiring savings, because Dean is going to use thinner wires. But most of that's going to come from redesigning the inverter. But let's be honest, I mean, just because you're stepping up the voltage, sometimes that's a huge step in design. That the we've seen quotes from manufacturers, not Power One, that their 1500 volt model is more expensive.
Even though it should theoretically be.
They all
less
acknowledge the
costly.
theory, but it's
Well, curious on just quickly on the certification process, the standards process. When can we start to expect, just not just UL recognized, but UL certified or, IAC certified?
I think UL still hasn't even converted it into a subject yet.
Yeah. So what does that mean? 3
That
years
means
off,
no
5 years
time
off?
soon. You could basically get a 1500 volt IEC listing, and you could get a recognized listing until they figure out what the protocol will be for testing.
Sure. Let's move
They
on.
need to have more solar guys on those boards at the certification level.
There you go. I think there might be a UL person or two running around here, so pin them down and see what you can do there.
We'll give them a black eye, don't worry.
Well, moving on maybe towards a little bit of the module technology. Another thing that people always talk about is higher efficiency modules, or maybe different module form factors as well, moving to like 84 or 96 cell instead of just the 72 cell that we have right now. What's the status on that, and are those promising avenues to, again, take out costs from the system?
I think, MJ, I'll take that one. Everyone's looking at every way to get cost out. On the large format, we all know the path from 60 to 72. 96, people don't like it because it's too heavy. It's 38 kilograms, 90 pounds.
You can't carry that?
Robots don't mind, of course. But I think that's one of the issues that has held it back. Even Germany still often uses 60s in utility because of labor and weight rules around moving stuff around sites. So I think you do need to have some type of technology change to really benefit from the larger form factor panels. But there's other things as well, right? So we talked about high efficiency. Yeah, I see it. I think you'll see very high 20% above efficiencies out of China. You've got a roadmap, that you guys look at. And then I've even, people keep playing around with bifacial for cleaning reasons and different mounting structures in Japan. And there is some interesting there if you can really fix albedo with it. So I think when I look at it though, the ones that are in hand and are going to be fast are A, the voltage, because everyone knows how to do that. 2, smart modules. And then whether it's going to be 96 cell or bifacial, that I think is still going to take a little time.
Sure. Okay. Anything to add, John or Dean?
I think if you go larger module, if you're going to go larger than 72 cell, you better go big, because as he mentioned, once you get beyond a single person's capacity to carry and you need lift assist or you're going to pre-panelize to some larger, frame, you might as well go really big and do that. And that
So 200 cell modules next year.
something. But it remains to be seen whether there's a value proposition for that. Because typically when, we think about an automated solution, I think about labor costs being high. But if at the same time we're driving down labor costs, then so the value proposition there is murky to me of the really large module. High efficiency, of course, everybody wants the 400 watt module, as soon as it comes out.
Is it going to be worth the cost premium though?
Oh, I see what you mean. You mean mono instead of poly?
Sure.
Or
Or
whatever?
any unit, or selective emitter, or name your fancy cell type.
It's good to see the module guys making money again because they can finally get back on their efficiency roadmaps. So
I think glass and glass comes out earlier and more broadly than that.
Yeah.
Dual glass. Just get wearing out.
I'm going to say the whole supply chain, from the modules to the power station, everybody's been squeezed to hell in the last 3 years. There's no doubt about it. Everybody's working for single-digit margin, and probably 80% of the people in solar are working in negative margins, trying to figure out how they're going to make their next payroll. And the only way till a new disruptive module comes out is how quickly you install the system and how quickly you commission it. When you're commissioning slow, you're going to install slow, you're going to have a bunch of labor sitting on a field. With our string level monitoring, what we're doing is we've implemented where we turn on our wireless device that we're partnered with Synapse, and we're commissioning a field string by string. So by the time you get to the end of the megawatt or megawatt and a half block, it works, you're done, put it away, go to the next block. And then the other thing we're bringing to help disrupt all this install is bringing out a monitoring cloud service with Synapse. So you could watch it being commissioned live. You could watch each string come on live. If you want to keep the wireless monitoring going, great, pay for it. If you want to turn it off, we don't care. But when you're done, from what our customers are telling us so far, they're seeing up to 30 to 40% cost savings in the labor side of installing a solar field. Because they're finding the broken modules, they're finding the guy who forgot to put fuses in the combiner, the guy who was, I'd say, hungover the night before and did a really shitty job throwing disconnects and installing wiring. All those things go away when you're commissioning at a string level basis. That's what's going to disrupt until somebody comes up with the crazy new module technology. And they could all talk all the crap they want, but there's nothing new coming out down the pike all that much that's going to disrupt modules, disrupt inverters.
Well, let's take one of these crazy module technologies that Mark actually briefly mentioned, which is smart modules, which is similar value proposition to part of its proposition is like string monitoring as well. That's a piece of it, but also some DC electrical balance of system savings as well. And Larry, maybe from a power electronics standpoint, are smart modules interesting to you guys? Is it something that you're looking at? And then John and Mark and Dean, for the BOS side, is this going to be real in utility scale solar?
Well, I think smart module is quite an interesting concept, and I think that with that, the inverter design can be simplified and can do its job even better. We'd like to see, the further development in that and how it's being adopted and embraced.
So what do you need to see from these independent smart module providers in order to feel comfortable with reducing the amount of stuff that goes into your inverter to work with them?
We'd like to see the adoption out there.
So you're just not seeing the demand pull for?
Honestly, we are not monitoring that closely, so this is something that we need to look into.
Okay. John, Mark, comments on smart modules. Are they going to help us in utility scale solar?
I don't know. It's a tough value proposition to sell me.
Mm-hmm.
I think it depends how smart and how much risk you're putting on the module. But when they're doing stuff that's inside the module, I think that becomes interesting because it fits well with the person who's already holding the warranty on the power, on the DC side. And so, again, it depends where you draw that line, but I think there is still some fit.
So
and
you
we'll go
wanna
on
see-
rooftops first, and then eventually we'll come to utility.
Let all the rooftop guys try it out.
Exactly.
Both of these things. I mean, the high efficiency module, there's a symbiotic relationship with the cost of microinverters, in my opinion. And that's going to hit the distributed generation market long before it hits the utility scale. And the same thing with pretty much any of those. That's how smart combiners and all these things, you know, they come that way through that avenue.
Sure.
But in utility scale, cost is king. Anything that's going to add functionality logically should increase the cost, and we can't stomach any of that right now.
So you guys, all right. So, you know, John, well, Mark, you work internationally. John, I believe you have international experience as well. And Dean, you guys have done projects. You know, what are some maybe the best practices that you're seeing coming out of, you know, whether that's Europe or some of the Asian projects that are being developed that you're not seeing in the U.S.?
We do business all over the world, and I think still the best systems I've seen being designed are either coming out of Germany or coming out of the United States, just because of the volume of installations that have occurred. We're doing business in Japan, and Japan is going through a learning curve, so they're about 6, 7, 8 years ago making the same simple mistakes we did either within Germany or the US. We're doing some business in the Middle East. Modules really aren't ready for those temperatures, just everything. And we're basically, in my view, probably an American installed EPC. It's probably one of the best out there and made for long-term reliability. Or German, not to make fun of anybody, but you know, we've just done so much of it and have learned so many of the failure modes that have occurred. And a lot of these up-and-coming countries like Japan and again Saudi and South America, they're making the very simple mistakes that we took care of 5 years ago.
Yeah, I might disagree with you slightly, Dean, just on one small point. I think where we're going now isn't beautiful Bavarian farmland or Southern California. And I think the ground risk, I think some of the soiling modeling is very different. You know, Saudi has 40% cumulative soiling. We don't design that in the systems in California. We let nature wash them. You know, I look at some of the salinity of some of the sites in Mexico and Chile, the corrosiveness. So I think what we have to do is we have to take those best practices, but I think we have to realize we have to design systems that are more robust than maybe what we've had in the past, because there's specific needs. South Africa, you know, it's got sinkholes, you know, it's got there's different issues. So I think there's an opportunity for the industry to take some of the best practices, but make sure they fit the new environment.
Amen.
All right, and so one final question before I open it up to the audience. So this question, your answer here can only be yes or no, followed by a number. So that's my caveat here. And so is there a bottom limit to where utility system costs can go? Let's say in the US, or if you want to do global, you can do global. And what is that number on a dollar per watt basis? There, you have no stake in this. You don't have to bid out projects, so you can throw whatever number you out there with no repercussions, right?
Yeah, and then, you know, make sure that I can still leave this panel in one piece. I can say that from the inverter perspectives, you know, we're not going to say what we think will be bottom line for the inverters, but we can look at places like China, for example, and of course we're talking about something with different standards and perhaps a different quality. We're looking at inverters at the utility scales at, you know, 7 cents, 8 cents per watt.
Okay.
So, you know, is this something we want to raise to the bottom over here to do that? Perhaps not, because I think that we have UL regulation, we have a certain level of safety and standards we need to follow. But, you know, that number bothers me a lot.
Sure. I gave you a little bit of a pass there, but how about the total utility system price and our total utility system cost, and, you know, is there a bottom there on the entire system?
I don't think I'm qualified to answer that question. Sorry.
Fair enough. John?
So you gave rules, right? Yes, there's a floor, and including the EPCs, OH&P, and everything BOS plus their OH&P, 45 cents a watt.
45 cents a watt. Including the module as well?
No, that's just the BOS.
Just the BOS.
Yeah,
okay.
but that includes substation, labor, you know, all that good stuff.
Sure. Mark?
Yes, there's always a floor, but we have to challenging it. I look at it, and we also have to think about this. We have to bring it down. after this, we have panel prices going up. We also have ITC expiration. So we have to design systems with 80-cent panels that can be put in full in at $1.40 and below, right? And I think that's doable today. I think that you and I always argue about this, MJ, but I look at it and it's fairly simple. Larry says that he's 10 cents.
No, 28 cents.
Yeah, but 10 cents for high quality, something that people would want to use.
Maybe, yeah.
You can do some skids as Dean was talking about. So there's opportunity still there. Panels, say they're 70 to 80. We don't know where they're going to be with this trade case. And then we've got to work the rest of the bucket. But I see a path there very clearly, including the fence, including the SCADA, including not leaving stuff out. But you have to do it, back to what we've said again, you can't do it the same way you did it. You've got to take labor out. It's a mass balance equation and a labor equation.
So $1.40 a watt today possible, but what about 5, 10 years when we hit this bottom?
Well, if I listen to your module pricing in the future, we'll get a lot further. But I don't control that piece. So I just think that we have to sit there and say, how do we compete 5, 6 cent? How do we compete against gas? Frack gas. What's that price going to be? And then the industry is finding its way there.
All right. Well, I'm going to ask you again after I find you during the reception. You've loosened up a little bit on that. Dean, how about you?
Yes, there is a bottom, because you could always give it away for free. Correct? Out of that,
you could pay people to give it to take it.
I mean,
right?
you could theoretically sell a site for no money. I mean, you'd be an idiot, but people pretty much are fighting in that space, because right now $1.40 is actually turning into a high number. Yeah. And I'm actually seeing people around the world fighting for $1 a watt, right? And that's beyond ridiculous, but people are quoting that craziness right now.
So what's more of a sustainable price that you would think?
The $1.35, $1.30, $1.35, that's sustainable, working its way down to $1. But I think to get to $1, you're probably looking 3, 4, 5 years out. Because everybody came from $3, $4 to $2 to $1.80 to $1.60. I mean, the utility price has been dropping like a rock. And at that point, you're going to get to where everybody's just going to bankroll and bankrupt selling a utility system.
Not if they fire all the licensed electricians first, though, right?
Even then, it's unsustainable, right?
Sure. Well, we have some minutes left. I know we have the reception afterwards, but let's open it up to the audience. Are there any questions from our audience members?
Any licensed electricians I've offended?
All right, well, maybe we'll just finish up with one question then from me, which is, looking at some opportunities beyond just solar, I'm curious if you guys have looked into things like storage as well as a way to add value to PV. And your experience, we've heard a bit this week about distributed storage, but I'm curious on the utility scale, how you guys see that factoring in. So Larry, maybe you can start for us.
Yes, I think that we're talking about utility scale now, and I think that's been proven out there that there is a value of storage. It may not be necessarily be integrated with the PV systems, but having storage alongside with the PV power plant will help increase the value proposition of the power plant quite a bit. And those benefits including providing or supplying the electrons at the time when it's needed the most, in effect, tame the duct. And also, with smart inverter technology, together with storage, the system can actually help stabilize in the grid. And the benefit with that will help the utility maybe delaying, further upgrades of the grid, or maybe even, increasing the capacity for a certain area. So being part of ABB, we have a very mature technology with, storage. And if you go to Puerto Rico, it's probably the place where there is probably the most adamant requirement of storage that go out together with PV systems. There are plenty of ABB power electronics being used now there together with storage to help with those kind of situations. So I think that is the, we talk a lot about residential and commercial where the value is high, but let's not forget at the utility level, with the right deployment of storage, I mean, there's equal or better value as well.
John, Mark, or Dean?
Sure.
Dean?
Um,
John, go ahead.
Sure.
Sorry.
So I'll answer this from a technology perspective and then real world perspective. So I don't think it makes sense at all for a PV plant to ever have storage, because if you're going to do that, if you have 20 PV plants on a grid, why wouldn't you have central storage that all of them have access to, instead of mandating that a PV plant has its own storage? So that's from a technology perspective, that makes more sense. However, from a regulatory and requirements perspective, it's much more difficult to say, you know, you're developing this PV project, and as part of it, to meet your requirements, you need 12% of that central storage unit is very difficult. So what we might see in reality is something like in Puerto Rico, where they put requirements on PV plants on downward ramp rates, or smoothing, or things like that, or even I've seen the duck curve 3 times today, and obviously that's easily solved by every PV plant having to have, you know, 3-hour load shift kind of capability of storage. So I'd like to see it centrally, but you know, in reality, we may see it as a requirement soon that PV needs to be able to shift its curve 3 hours or something like that.
So from a Shoals perspective, we kind of gone to the dark side and have entered into the oil and gas industry with our products. And we are now developed and basically making a multi-megawatt kit that has a PV field, a DC genset, and a battery storage to run off-grid in the Middle East, and basically run power for 24 hours, no grid anywhere to be found. So from my perspective, I'm 180 degrees out of that. We're designing in battery systems to completely run critical power systems and very high generating money makers, that there's no high tension lines to get out to these fields.
It's a disconnected system, though, right?
Disconnected.
It's its own
Yeah.
off-grid
Yeah.
system. Yeah.
And then even from there, about every other RFQ we're seeing, there's some kind of battery storage that needs to be attached to it at the megawatt skid.
Great to hear. So we're running out of time. You know, storage is actually a great topic that I wish we had a lot of time to talk about. So, you know, when you're filling out those surveys, you know, put that in, so next year I can have more of a storage panel as well. But in any case, to summarize, you know, Larry's going to sell all of you 7-cent a watt inverters. John doesn't want to see any costs, anything that will add cost to systems at this point. And both Market and Dean are on a rampage to get rid of as many installers and licensed electricians as out in the field as possible.
In order to grow the industry.
No, these guys have a lot of experience, behind them. They're a great resource. I hope you guys find them after, ask them questions. And, from now, so we will move directly into the networking reception, which is at the Litchfield lawn. If you were here yesterday for the reception, it's in the same place. It's officially going to, it says 7:45 on the program, but Shoals has generously donated some extra time to us, so there will be open bar till 10 o'clock. Thank you guys all for attending this session, and please give these guys a round of applause.